Okay, so first I would like to go over just to overview what we talked about last Friday. So last Friday was the first day we talked about inverse trig functions. And so we first talked about why we asked the questions of one-to-one function. Well, it brought us back to algebra 2. You remember learning quadratic functions in algebra 2. And then right after that unit, we talked about the inverse functions of a quadratic, which is a square root. But if we just swap the x and y, make the graph, and we quickly bump into a problem that is, well, it's not a function. So we asked the questions of how can we make the inverse and also the inverse being a function itself. So we say, well, let's go ahead and restrict the domain. Let's go ahead, for example, restrict the domain from 0 to infinity so that we have a square root, a positive square root graph shown on the right-hand side. So we want to make sure that the original function is a one-to-one function so that the inverse is also a function. If the original function is not a one-to-one function, then we must do something. And this something is the restriction of domain. Okay. And everyone should be fully capable of graphing a sine graph and cosine graph. And we ask the question, is this a one-to-one function? And the answer is no. And the problem of not being a one-to-one function is that if you swap the x and y, well, that's what it is, and it is not a function. So we say, well, we have to restrict our domain. Well, which portion of the graph should we restrict so that we have a one-to-one function? Now, it's very important that you have these graph sketches in your head because you will need to know these restrictions by heart. But should you memorize, like hard memorize to your brain? Or should you refer to the graph and get it from the graph? Well, I would always look at the graph and tell the restriction. Because if I just memorize a table on your next page, I'm afraid that I might memorize something wrong. I need something more solid to back myself up. So the graph, it's going to be a very good way to back myself up. So for cosine, we will restrict to quadrants 1 and 2. Quadrant 1 will always be the positive value, and we will select quadrant 2 because that would cover the negative value portion. It would not be quadrant 4 because if it's quadrant 4 and quadrant 1, that will not be a one-to-one function. So that's a very easy selection. And then once we have those points, we will plot those points. We swap the x and y, and then we draw the line. And how do we know that we draw the line properly? How do we know that we draw the line properly? Not the wrong way. Yeah, if you rotate the graph, if you rotate the paper 90 degrees, then it should resemble, it should look like part of the cosine graph. If it does not resemble a part of the cosine graph, then there's a problem. Right, so same thing with sine. We will say we'll restrict the quadrants to quadrant 1 and 4 because quadrant 2 would not make it a one-to-one function. So it's very easy. And if you know sine and cosine's restrictions, then you would also know secant and cosecant restrictions. And last Friday, I also asked you to draw the sketch of a tangent graph and cotangent graph, and then you will know why we have those restrictions. Okay. Now, before we left the class last Friday, we went over these problems. Now, it's very important that you know these fractions that you're reading right here inside the inverse trig function. These are ratios. So the inverse trig function of a ratio gives you an angle. Now, if it's a positive ratio, then, well, it's going to be a quadrant 1 angle, so nothing to worry about. Then you only need to worry something if you see a negative, because that tells you it's not negative, it's not quadrant 1, so you need to know your restriction so that you can tell your quadrant. So if it's a negative ratio inside the inverse sign, that means it must be in quadrant 4. And then we say, well, it's an angle and sitting in quadrant 4, and cosine of that particular angle, which is negative pi over 4, will give you a positive value. So that's how you know whether it's going to be a positive or negative value. You have to follow through the step-by-step thought process. Now today, we'll cover part 4. Now for part 4, you still have a ratio right here, but it's not one of those you have seen from the unit circle. So this one is a 4 over 5. So this 4 over 5 means what? Okay. So if it's inside the inverse sine function and it's 4 over 5, that means it's a ratio of which two sides? So you can go ahead and label opposite and hypotenuse. All right, so this will involve you drawing a little triangle. You can label that theta. Now, we are not trying to find out what the theta is, but we'll label them. We'll label the angle. And if you draw this triangle on your paper, I hope there's a number screaming in your head right now. What's the number? The number is 3. Okay, I hope that number 3 is screaming in your head because you cannot miss a 3, 4, 5 triangle. And then we say, oh, excuse me, can you give me the cosine of this angle, please? Well, cosine of this angle, it's adjacent over hypotenuse. So therefore, you just provide the ratio. So again, we are not trying to find out this particular angle's value. We're not trying to find out the angle's value. We are trying to find out the cosine of this angle. And again, the ratio is positive. So this is simply a quadrant 1 angle. So we don't really have to worry about the sign. It's going to stay positive. Okay, any question for number 11? Well, let's go ahead and take a look at number 12. So we have a negative ratio sitting inside the arc cosine. So, all right. Well, if that's the case, what kind of information can we tell from this expression here? This angle must be in quadrant. Nope. Quadrant 2. Right? Look at the table at the top. If the inverse cosine of the value inside the inverse cosine is negative, that tells you it's an angle sitting in quadrant 2. That's why we need to know the restrictions. All right. Now, if you're tempted to say quadrant 4, how can you argue your way out? That's not quadrant 4. Yeah, well, if it's quadrant 4, then the cosine is positive. But this is negative. That won't be quadrant 4. That cannot be quadrant 4. Right? And then the next piece of information you have that you have here, it's that cosine, it's 5 over cosine of the angle, it's 5 over 13. That means adjacent is 5. Hypotenuse is 13. And at this moment, there should be a number screaming in your head. And that number is? What's that number? 12. So now for like 3, 4, 5, 5, 12, 13, those are Pythagorean triplets. If you're taking the SAT, you should really know them by heart. And then we have tangent of this quadrant 2 angle. So should it be positive or negative? Okay, think about A, S, T, C. So tangent of an angle that's sitting in the second quadrant must be negative. And we do opposite of adjacent, so negative 12/5. That would be our final answer. All right, I will let you try number 13 on your own. Give it a shot. Number 13. So you always ask yourself, okay, this is an angle, so what quadrant does it sit in? Okay, which quadrant does it reside? So for this case, it will be in quadrant 4. It'll be in quadrant 4. Okay. It'll be in quadrant 4. And the triangle that we're going to draw, it's going to be like this. Now, it doesn't have to be perfectly accurate, but I mean, it should make some sense relatively. Like if the ratio it's 1/5, that means it should have opposite being 1, hypotenuse being 5. So at least it makes somewhat sense. And then now, as you know, I'm not a big fan of secant, cosecant, or cotangent. So if I'm looking at secant, you know what I would do? I'm going to figure out the cosine theta first. And then I'll do the reciprocal at the end. So I'm going to ask the question, well, what's the cosine theta in this case? Well, that would require me to find out the adjacent side. What's the adjacent side? Two. It should not be 2. It's 2√6, or you should get square root 24, and then you reduce it to 2√6. So for the cosine theta, you will have 2√6/5, and then you do the reciprocal of that. So 5/2√6, and you need to rationalize it, and that it becomes 5√6/12. So again, drawing a triangle, we're not really finding out what the theta is. We're just interested in what the ratio is. And then for number 14, now for number 14, it looks a little bit strange because it doesn't have a ratio, or do we? Do we have a ratio here? We're looking at x by itself, but we can interpret x as a ratio, that is x/1. And if you can express that x as x/1, then you have yourself a right triangle, which is x as the opposite and 1 as the hypotenuse. And this is positive, so it's in quadrant 1, so you don't have to worry about the sign. So you can work out the adjacent side, and the adjacent side will be 1 minus x squared. So cosine of this angle would be square root of 1 minus x squared over 1, or you can just write down square root of 1 minus x squared. Okay, now you should have enough information to finish all the questions on the next page. All the questions that does not involve graphing, you should be able to do them on this packet and also the one that you received today. So please finish them tonight. And then tomorrow when you come back, we'll focus on the graphing stuff.